Hello, welcome back to Teach Engineering and Technology Solutions. Now, we are going to look at moments. Moments are important because they have application in engineering, science, mathematics, technology, in fact, all aspects relating to building, construction, designing of machines, aeroplanes, cars. So we are going to look at how we can actually model a particular situation using moments. Now, what is moment? Moment equals to force times the perpendicular distance from the pivot. We're going to look at a typical example. For instance, how are we going to model a bridge? We know situations where we have to pull over a bridge or pull up a bridge for ships to pass, especially in London. Now, this is a typical example. We're going to look at how we can model a particular situation where we have to open a bridge. Now, why we model this particular situation is because we need to know the magnitude of force which we can actually apply and at what angle. So let's have this example here. We have this bridge which is to be opened. Now, a 6 kilonewton force is actually applied horizontally to open the bridge. This is the bridge here. Normally the bridge attaches itself on these 2 points and it is supported by these 2 pillars. But we're not going to work on support. We're going to work on moments. Now, this bridge is pulled up using a horizontal force. Now, it is assumed that the bridge has is uniform in cross-section and material, and that the weight acts directly in the middle. So the force we have horizontally is 6 kilonewtons. The force downward 8 kilonewtons, which is the weight. If we are to raise the bridge, prove that this angle, the tan of this alpha, would be greater than 2/3. So how are we going to approach this particular situation? The first thing is to actually draw the force diagram. Firstly, 6 kilonewtons horizontally. Now, we have our bridge. It's kilonewtons. Okay, this is alpha. By trigonometry and geometry, this should be alpha as well. So we have 2 angles here. Alpha. Right. Now, this is x, this distance, and this distance also is x because the weight acts directly in the middle of the bridge. So this is our bridge here, this is our horizontal force, and this is our vertical force. Right, now, how are we going to apply moments now? We have to realize that moment is equals to the force times the perpendicular distance from the pivot. Now we'll come back to our original diagram. That is our pivot because that is where the bridge is, from where the bridge is raised, clockwise. Now, this force, which is the horizontal force, has to be perpendicular to that pivot here. So if we actually extend the line of force, let's remove this arrow, so that we'll be able to actually include our perpendicular distance. So if we